Welcome to another audio article in our History of Science series, where we explore the ideas and instruments that quietly transformed how we understand the natural world. Some discoveries arrive with dramatic experiments or bold equations. Others are far quieter but no less revolutionary. Today's story is about one such transformation, how scientists learned to measure temperature. For most of human history, heat could be felt but not measured. Fire was hot, ice was cold, and one day felt warmer than another. But there were no numbers to describe those sensations. This posed a serious problem for early science and medicine. Without measurement, heat remained subjective. What felt warm to one person might feel cool to another, and observations could not be reliably compared. Turning temperature into something measurable required new instruments and a willingness to move beyond human sensation. The first major step came in the early 17th century with Galileo Galilei. Around 1593, Galileo devised an instrument now known as the thermoscope. It consisted of a glass bulb attached to a tube with the open end placed in water. As the air inside the bulb warmed, it expanded and pushed the water level down. As it cooled, the water rose. The device clearly responded to changes in heat, showing that temperature produced observable physical effects. However, it was not yet a true thermometer. It had no scale and was affected by air pressure, so it could only show that temperature had changed, not by how much. Still, it marked a turning point. Heat was no longer purely subjective. Progress continued when scientists began sealing these instruments and replacing air with liquids. Sealing the tube eliminated the influence of atmospheric pressure, making readings more reliable. Liquids such as alcohol and mercury expanded and contracted in response to temperature changes. Alcohol was sensitive to small changes, while mercury expanded in a nearly uniform way over a wide temperature range. By the mid-17th century, sealed liquid thermometers were common across Europe, yet readings still varied widely because there was no agreed-upon scale. Early thermometers used arbitrary markings. One might be divided into 10 parts, another into 50, and another into 100. Two instruments placed side by side could give very different readings. Scientists soon realized that reliable temperature measurement required fixed reference points that could be reproduced anywhere. Natural events such as the freezing and boiling of water became obvious choices. A major breakthrough came in the early 18th century with Daniel Gabriel Fahrenheit. Fahrenheit refined the mercury thermometer and introduced a consistent temperature scale based on carefully chosen reference points. His instruments were precise and reproducible, allowing thermometers made in different places to agree for the first time. Soon afterward, Anders Celsius proposed a simpler system based on two fixed points, the freezing and boiling of water, divided into 100 equal steps. Although his original scale was inverted, it was later reversed into the form now widely used. Temperature had become a standardized quantity rather than a matter of local convention. With reliable thermometers and agreed-upon scales, scientists could finally investigate deeper questions about heat itself. They began to distinguish between heat as energy in transfer and temperature as a measure of a system's thermal state. This distinction laid the foundation for thermodynamics and reshaped fields such as chemistry and engineering. The thermometer's impact extended far beyond physics. In medicine, it turned fever from a vague sensation into a measurable condition. In chemistry, it allowed reactions to be controlled and repeated. In meteorology, systematic temperature records made it possible to study weather patterns over time. The invention of the thermometer marked a quiet but profound revolution. It took something deeply human, our sensation of heat, and placed it into an instrument. Temperature became a number rather than a feeling, a quantity rather than a guess. With that shift, science gained a new level of clarity, 1 degree at a time. Thank you for watching another episode in our History of Science series. More stories coming soon.